Okay, today I'm going to talk to you about acceleration. I'm also going to show you how to use this particular equation and how it relates to real life situations involving acceleration. So what does acceleration actually mean? All acceleration means is a change in velocity. Remember, velocity is just how fast something's going. So if something starts off slow and then gets faster, increases velocity, is accelerating. But if it starts off fast and then slows down, it is decelerating. So let's see how this equation here relates to a real life example. And I'm going to do a real life example involving a car. So let's say here is my car right here. We're going to see how we're going to calculate the acceleration from this car going from stood still to moving at a speed of 50 meters per second. Okay, so the first thing that we're going to think about is our starting point. Now let's say this car is stationary, it is still. If it's stationary, it is going to have a speed of 0 meters per second. Now how does this relate to this equation here? Now this letter here, u, that is our initial velocity. So that's how fast this is moving to begin with. So we can see to begin with, this is going to be travelling at 0. We'll put the numbers in a minute. Now, let's say this car has sped up to a speed of 50 meters per second. So we can see this v here, that is our final velocity of 50 meters per second. So in a second, when we put the numbers in, we can start to see where they go. But to calculate acceleration, we need to know how long has this change in velocity occurred over. So let's say it's taken us 10 seconds to go from stationary to 50 meters per second. Now this t here simply stands for time. So let's try and put these numbers in. Now remember our final velocity was 50. Our initial velocity was 0. Oh, sorry, I did it in the wrong colour. Was 0. And our time taken was 10 seconds. So 50 take away 0 is just 50. And 50 divided by 10, because it took 10 seconds, is 5. And that gives us our A, and obviously our A stands for acceleration. Now the units for acceleration is meters per second squared. Now this shows acceleration, but can we also do this to show deceleration? Let's imagine the same car now. Oh, my drawings are getting worse of this car. Let's say this car now, instead of speeding up, it slows down from, let's say here, it's now travelling at 50 meters per second. So at the beginning of this one, so this is a different question. This time we've got this car that starts off travelling at 50 meters per second. And then it slams on the brakes and slows down to being completely stationary. So let's say this time it takes 5 seconds to do that because it was slamming on the brakes. Let's see how this changes our calculation. So our final velocity this time is going to be 0 because we've come to a halt. It's not moving, it's travelling at a speed of 0 meters per second. Our initial velocity, we started off, this car was travelling at 50 meters per second. And then we're going to divide that answer by how long it took the car to brake, which is 5 seconds. Okay? Now, be careful with this bit here. We can see that it's 0 take away 50. So on top, we're going to have minus 50. And on the bottom, we're just going to have 5 because it's taken 5 seconds for it to slow down. So minus 50 divided by 5 gives us our acceleration, which is 10 meters per second squared. Okay? Minus 10 meters per second squared. Now we can notice if we have a minus velocity, a minus acceleration like this, it shows us that our object has slowed down. So that's how all of these different parts of the equation relate to real life situations. And remember, if we've got a negative number, a negative acceleration, it shows that our object has slowed down. Thank you.